I promised you that this is going to be leading to something, but I got to do this podcast at this point. And then you'll understand what reference angles are all about. As soon as I finish this and show you the example, it's amazing. So bear with me as we go through this. This is called special right triangles. That becomes extremely important in Math 30-1 and 30-2. And this is for anything that has an angle of 30, 45, and 60. You can actually determine the exact values. And you're probably saying, wait a second, what do you mean exact values? Are we dealing with roots again? Oh yeah, baby, we certainly are. Take a look at this one. I've got a 45, 45, 90 degree triangle, which of course is isosceles. So there's my 45 degrees. There's my other 45 degrees. There's my 90 degrees. And yep, we're going to bring in our favorite SOHCAHTOA one more time. Okay, but wait a second. How does this work? Well, you know and I know that these two, being that they're isosceles, means that these two sides are the same. So let's just kind of call it a side of 1, and this a side of 1. Now, my question is, what is that side going to be? Well, you can just introduce a squared plus b squared equals c squared into this mix. Why not? This is your a is 1. This is your b is 1, so 1 squared plus 1 squared equals c squared. Oh my goodness, this is tough. That's 1. That's 1 equals to c squared, so c equals to root 2. Interesting. So that, in fact, is root 2. That, sorry folks, gotta memorize it. But it's easy. If you can't remember it, you can figure it out. Just remember, this and this are the same. That looks like a 1. That looks like a 1. 1 and 1, 1 squared, blah, blah, blah. You get your root 2, right? Okay, good. Let's go to this one now. This one's a little bit tougher to remember. This is called a 30, 60, 90 triangle. Obviously, there's your 60, there's your 30, there's your 90. Now, how do you remember this? It sounds really, really silly, but you know what? This just helps you to memorize this so well. 30 to me is a small, light angle. Why do I say light? Well, because 60 degrees is a heavier, it's a bigger angle, it's heavier. Heavier sinks to the bottom, 30 floats to the top. So, what happens here, this is 30, that's 60, easy to do. Now, all you have to do now is count. What do you mean count? Start at the bottom, 1, count, 2, count, 3, that's it. Now, wait a second, is that really right? Well, not really, because you know that the longest side is a hypotenuse, and that of course has to be the longest. But the way I've written it as 1, 2, 3, that's not the longest. So how do you remember? This is not making sense yet. Well, we'll in a second, because that's not 3, that's actually root 3. Remember, we're dealing with exact values. Answers involving radicals. Okay, so I'm not going to put this down as some sort of 1 point blah 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 blah. I'm just going to leave it as root 3, and that's going to help us an awful lot. So, okay, let's try this all over again. Here we go. Ready? I'm going to erase a whole lot. I'm going to try it all over again and see if we can remember a few things. Okay, first things first. Here's our 45, 45 degree triangle. That and that are the same. So guess what? Treat those as 1s. That's 1, that's 1. A squared plus b squared equals c squared. 1 squared plus 1 squared equals c squared. That's 1 plus 1 equals c squared. C has to be equal to, or c squared equals to 2. Square root, c has to equal to root 2. There's your 45, 45, 90 triangle. 1, 1, root 2. Real easy to remember. This is your 30, 60, 90 triangle. 60 is heavier, sinks to the bottom. 30's lighter, floats to the top. There's your 90. Count. 1, 2, root 3. Done. See? Perfect. Now, how does this help us here? Well, watch this. We're actually going to get perfect results here. Watch. Remember SOHCAHTOA? Do you remember SOHCAHTOA? Sine is the opposite over hypotenuse. Cosine is the adjacent over the hypotenuse. Tangent is the opposite over adjacent. And it always gave you some sort of crazy decimal, right? Watch this. If you use sine of 45 degrees, opposite. So this is a 45 degree right here. Opposite would be 1 over hypotenuse. Well, hypotenuse is root 2. Done. Sine of 45 degrees is 1 over root 2. If you do not believe me, check this. Sine of 45 degrees, boom, is that number. Go 1 divided by the second square root of 2. Watch this. This will freak you out. Same number. This number looks a heck of a lot prettier than that ugly thing, doesn't it? But the sine of 45 degrees is now an exact number. Yay! No more run-on decimals that drive you crazy. No more irrational numbers. We can now deal with exact numbers. That's what's so important about this concept. Okay, let's go back. So what is the cosine of 45 degrees? Remember, there's your 45 degrees. Cosine is adjacent over hypotenuse. Well, adjacent is also 1. Hypotenuse is root 2. Wait a second. You're telling me the cosine of 45 is going to give me the same silly number? Yes, I'll prove it. The cosine of 45 degrees, enter. There it is. It's the same number. Isn't that wild? Okay, let's go. Then what is tangent then? Tangent, if you remember, is opposite over adjacent. There's opposite, there's adjacent. So opposite over adjacent is 1 over 1. Well, tangent of 45 degrees is just 1. Let's prove it. Tan 45. It's 1. Wow. Well, then let's burn through the rest of this a lot faster. Sine of 30 degrees. Well, there's 30 degrees. Sine, of course, opposite over hypotenuse. Opposite is 1. Hypotenuse is 2. The sine of 30 degrees is 1 over 2. The cosine of 30 degrees, adjacent over hypotenuse. Adjacent is root 3. Hypotenuse is 2. Root 3 over 2. There's your cosine of 30 degrees. Tangent, opposite over adjacent. TOA, right? Opposite, which is 1. Adjacent, which is root 3. There's your exact value of the tangent of 30 degrees. Do the same thing now to the sines. Sine of 60. There's 60 degrees. Opposite is root 3. Hypotenuse is still 2. Root 3 over 2. Cosine of 60 degrees is adjacent, which is 1 over hypotenuse. That's 1/2. And tangent of 60 would be opposite over adjacent, which would be root 3 over 1, or just plain old root 3. That's how all of this works. Isn't that amazing? It's so cool to see this as exact numbers. And then you can say, well, look at this. Look how sine of 30 and cos of 60 are exactly the same number. Well, that can't be true, can it? Let's check. Sine of 60, or sorry, sine of 30 and cos of 60. Cos of 60 better be the same numbers. And oh my goodness, they are. Isn't that neat? Look at all the tremendous relationships here. You can say the cos of 30 and the sine of 60 are the same value. And look at your tangents. The tangents, if you think about it, are just reciprocals of each other. Tangent of 30 is 1 over root 3. Tangent of 60 is root 3 over 1. Isn't that neat to see the patterns? And remember, all mathematics is a pattern.